Hi, this is King of Review. If A is a square matrix of order 2, which always satisfies A plus A inverse equals E, which of the following is equal to A to the power of 2015, where E is an identity matrix? So let's start with this equation here. We have A plus A inverse equals the identity matrix E. I want to start by multiplying both sides by A. So I have A times this side, A plus A inverse, and this is equal to A times E. So if I distribute this A, I get A squared plus A times A inverse equals AE. Now I want you to remember the fact that if we multiply A times its inverse, which is A inverse, you're going to get the identity matrix. And if you remember, the identity matrix has a 1s in the main diagonals and 0 everywhere else. One feature about the identity matrix is if you multiply a matrix times the identity matrix, you'll get the original matrix. Or you can also have E times A, which will give A. So let's look at our problem over here. Here we have A times its inverse. So we know that that must equal the identity matrix. And here we have A times the identity matrix. So that follows this situation here. So we know that this must equal A, because a matrix times an identity matrix equals the original matrix A. So we have A squared plus E equals A. Now let's rearrange so we solve for A squared. So I'm going to subtract the E on both sides. So I have A squared equals A minus E. So we know what A squared is. Now let's figure out what A cubed is. Well, A cubed is the same thing as A squared times A. We know what A squared is. That's A minus E. And then we have times A. So here I'm going to distribute this A. So this gives me A squared minus EA. Now again, we see E times A here, and we know that must equal A. So this is equal to A squared minus A. We also know what A squared is because we solved for that here. So we have A minus E, that's A squared, and then minus A. So A minus E minus A, well, these A's cancel out, and you're left with minus E, or -1 times the identity matrix. So now we know what A cubed is. And finally, let's figure out what A to the 6th power is. Well, A to the 6th power, this is the same thing as A cubed raised to the power of 2, because 3 times 2 gives us the 6. We know what A cubed is. We solved for that. It's -E. So we have -E squared. -E times itself. This is -E times -E, and this equals E. So now we've also solved for A to the power of 6. So what I want to do is use these three values, A squared, A cubed, and A to the power of 6, to find A to the power of 2015. So A to the power of 2015, this can be written as A to the power of 2010 times a to the power of 5. Why is this? Well, if you remember back in exponents, if we have x to the power of a times x to the power of b, because we have two exponents that have the same base and we're multiplying them together, you can go ahead and add the exponents. So this is that rule backwards. A is the base and they're the same, so we can add the exponents. 2010 plus 5 gives us 2015. So now we want to write these in terms of a squared, a cubed, and a to the power of 6. So we can rewrite a to the power of 2010 as a to the power of 6 raised to the power of 335. Because 6 times 335 gives us 2010. And then a to the power of 5, this can be rewritten as a cubed times a to the power of 2, because 3 plus 2 gives us the 5. So now you see we have a to the power of 6 and a cubed, and we know what those values are here. So we have a to the power of 6, and we know that's equal to e, so we have e raised to the power of 335 times a cubed. We know what that is. That's negative e. Negative e times a squared. So e times itself 335 times, that's just equal to e. So if e times negative e times a squared, we know that these identity matrices here follow this rule. When we multiply a matrix times an identity matrix, you get the original matrix. So here, we're left with negative a squared. And we know what a squared is. We solved for that here. So this is equal to negative, and then a squared is a minus e. Again, we solved for that here, so we know what a squared is. And now just distribute the negative sign, so we have negative a plus e, and another way of writing this is e minus a. So this is our final answer. Letter D is correct. Thanks for watching.